Okay. Father in heaven, thank you for this day. We are grateful to be able to have this morning and to be able to meet together and to take our group quiz together. We are grateful for all the resources that we have to study and learn about this statistics class that we're taking. We ask to have the Spirit with us that we may be able to understand the material and to help each other if needs be. We ask and pray for these things in the name of Jesus Christ. Amen.
Amen.
All right. So I just opened up the quiz. Let's see. I'll take the question 3. Are you there?
Yeah.
Okay.
You're still open.
All right.
Okay.
Oh yeah, sorry. Are you at the quiz already?
Yeah.
Oh. All right. Sorry, I thought you weren't there. My bad. Okay, for question 3, it asks the symbol for the true population proportion is which of the following? P squiggly line, P hat, and then P. I'm going to go with just P.
Information for the next 2 questions. Suppose n p equals 0.25 and p hat equals 0.19. Constructing confidence stars.
Okay, sorry, I was just doing the work. So we got true, right?
Yeah.
Okay. The requirements for conducting a hypothesis test are satisfied. I would say yes. True.
Is it like the same for hypothesis and the confidence interval?
Yeah, well, the hypothesis tests, the requirements are that the sample is obtained from a simple random sample, but we don't really know anything like that. And it does have to be greater than 10, and those are really the only
Okay.
two things.
Cool.
All right.
The following information for the next 5 questions. First degree murder trial was conducted in another state. A random sample of 60 people on trial for first degree murder. Of these, 45 of the defendants were found guilty. Find the total estimate of the proportion of the first degree murder defendants were found guilty in this state. Over N, right? So the
Yeah, 0.75. Okay. For question 7, well, before that, it says create a 95% confidence interval for the true population of first degree murder trials in this state. Of first degree murder trials in the state, the verdict is guilty. Input your answers for the margin of error, lower bound and upper bound. Determine the margin of error for this 95% confidence interval. Round to 3 decimal places. Okay. So I got 0.11 for the margin of error.
So did you do the your keyboard? You ever n squared times 2 times 1 minus 2?
No, I used I'll do this. So I used the z times the square root of p hat, 1 minus p hat, and that's over n. The ones you were talking about is for finding the sample size.
Oh.
Yeah, I was doing that one too at first, and I was like, wait, we don't even have the p. What do they call it? The prior estimate.
Yeah. You said it was 0.111.
Yeah, 0.11.
Okay.
Yeah. Yeah, I got. Oh, sorry. I was just saying that I got 0.109, so that I changed it to 0.11.
It says input the lower bound. That would be so, this is one thing I'm confused on right now. Do the proportion, or are we using like the full? Like, you would do 45 minus 0.11 or 0.75 minus 0.11.
I think it would be 60 minus 11.
That's the sample size, isn't it?
Yeah, that would be n.
That's what you use the reference point in.
Yeah,
Because
that would be.
it couldn't go over 60. So that sense is that's not like
Oh no, what you're right. You're right. It would be p hat plus or minus whatever the confidence interval was. So it'd be 0.75 plus or minus the 0.11. You're right.
yeah. 6.4.
And for
11, is it?
no, no, yeah, because I even used the Excel sheet, and then I got 0.64 as the lower bound too, and then for the upper bound it was 0.86.
If the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? We would expect it to increase, right? Well, actually, the same to its with the proportion, wouldn't it?
It would decrease the confidence interval. Like the numbers would be closer.
Oh, okay. I was just thinking of like, so I guess, so we're talking about increasing it, but the same.
Oh, I don't know. I took notes where the teacher said when the confidence increases, like if we're 99% confident compared to 95, the interval is going to increase. So you know that we have a better chance of being 99% confident. But if the sample size increases, then the interval is going to decrease. That's just what I wrote down.
Okay.
Yeah. Okay, for question 11, to conduct a hypothesis test for one proportion, two requirements must be met. Suppose that p equals 1/2. What is the smallest n can be, and both requirements still be met? All right. So that'd be 0.5 if p equals 0.5. Shoot, I don't know.
It'd just be 50, wouldn't it? Yeah. Oh no. Hang on. So it's a hypothesis test, which means you need a large enough sample, right? So it has to be over 30. To, like, if we just use 30, for example, that's the smallest that we can have on one side. It still meets the other requirement for the equation side. Then we should be doing times 0.5 is 15. 30 times 1 minus 0.5, which is 0.5 is 15, so that's greater than or equal to
10.
10. But we still need at least 30. If it's like 20, so it's greater than or equal to 10, but 30 seconds. 0.5.
Yeah. So just you go with 30 then?
Yeah.
Okay.
So, to conduct a hypothesis test for one proportion, what is the smallest n can be in both requirements? And would need to be 100.
would be 100.
Yeah, that's right.
Okay. Is that what you said?
Yeah.
Okay. Sorry. For question 13, for the water quality study in the reading, about 60% of the macro invertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using a significance level of A equals 0.05, with the following hypothesis that the null is equal to 0.6 and that the alternative is less than 0.6. They collect new data, and this time n equals 80 and x equals 38. Indicate good health. The conditions for conducting a hypothesis test are satisfied. Let's see. True, I would say true.
Question 14, what is T hat?
Did you say 0.475?
Yeah.
Let me go back and do it again. I got 0.438. What the heck? Yeah, I don't know what happened the first time. I got 0.475. Okay.
Yeah.
Find the test statistic. Okay.
For this one, it's just the Z-score, right?
Yeah. Okay, for the z-score, I got negative 2.282.
Yeah, I see that. What is the p-value for this test? I got 0.011.
So the decision for this test would be to reject the null since 0.11 is less than the 0.05.
Question 18. Which of the following best summarizes the conclusion of this test? Sufficient evidence to conclude that the water quality was not decreased. There's sufficient evidence to conclude that water quality in the area has not decreased. There is insufficient evidence to conclude that water quality in the area has decreased. Sufficient evidence to conclude that water quality in the area has decreased. I'll get the last one on that.
Yeah. Yep. Man, it's taking forever this time.
Looks like we got question 11 wrong.
Which one?
It's the one where we said we have to have at least
Oh, yeah, that's the only one I got wrong too. Well, is that the only one you got wrong?
yeah.
Okay.
One.
I think the answer for that would be 20 now. Because if you do 20 times 0.5, that would make 10. And then 1 minus 0.5 would be 0.5. So 20 times 0.5 again would be 10.
My only question is, doesn't it have to test? Because they're like a hypothesis, it has to be like large enough to have a normal distribution, and outside of sample size, we don't have a way to tell the distribution.
Yeah. I don't know. That's just the only other thing that came to mind.
Cool.
I don't know.
When you post it, you want to like post in the picture that's for to ask that question, because it's being new. Have to use that one. You can get it.
You're asking for question 11, right?
Yeah.
Okay.
Yeah.
Yeah.
So, or I can comment after you posted it that way. Yeah.
All right. Okay. Yeah, I'll post it in a bit.
Cool.
All right. Well, I guess I will see you on Tuesday, and I'll send you that document half an hour to an hour.
All right. Well, I'll try and start my brainstorming areas we can pull something from.
All right. Cool. All right. I'll see you next time. Bye.